Hi everyone, this is WWD Draft and you are most welcome for it. I'm 95% sure that any data analyst out there or anyone who uses data has ever used percentage before. But some people do use percentages when they do not know exactly what it means. That's why in this video and some few videos to come, we're going to drill deeper into understanding percentages, and we shall also jump into Excel and we learn the proper ways of using percentages in Excel. Let's switch on into the main point of this video and we dive deeper into understanding percentages. Now the word percentage, or in short percent, actually means the same thing, but when it comes to constructing sentences, the two words are used differently. We shall get to that in a future video when we already know what percentage or percent is. Now the word percent actually comes from the Latin word percentum. Per means for every, and centum means 100. So literally, percent means for every 100. Now when you see that sentence for every 100, it looks like it's not complete. It needs to be some number for every 100. Now that number P is actually what we always calculate when we are getting percentage. Like for example, when you see a number like this symbol here is actually the percentage symbol or the percent symbol. Now when you see a number like 10%, it actually means 10 for every 100. That's actually the rational form for 10%. And when you see a number like 66%, it actually means 66 for every 100. Now this is the numerator and this is the denominator. When you see those two ratios, on the denominator there is always that 100. So what mathematicians did, instead of repeating that 100 each and every time you want a percent, they decided to bring a symbol, the percentage symbol, that you can just put in front of the number which is on the numerator, and it will represent that 100 which is on the denominator. So when you see 10% or 66% or 1% or any percent, you should put at the back of your mind that there's actually some 100 at the denominator which is being represented by the percentage symbol. Now when you already know this, it's actually very easy for you to understand percentages. Now let's move on. Percentage or percent is actually calculated using the formula part divided by the total. This is the universal formula that is used to calculate percentage. Now, in order for us to understand this formula very well and also to understand percentage, let's do an example. If we have a question like this, 55 out of 100 workers are ladies. What is the percentage of the ladies at work? The 100 workers is actually the total number of workers, and that one is going to be our total. The 55 is actually just part of the 100, and that one is going to be our part. So what we are interested in is calculating the percentage. We can actually use our formula above, and we already know that percent, which is actually some number, like for our case here we are calling it P for every 100, equals to part, which is actually 55, divided by the total, which is actually 100. Now since we are interested in getting that P, or that number P, we need to get rid of the 100 which is on the left hand side of the equal sign. So since that 100 is on the denominator, we need to multiply both sides by that 100 so that we can get rid of it. So I'm going to multiply the left hand side by 100 and also multiply the right hand side by 100. So what I need to do now, I'm going to cancel this 100 and this 100, and on the left hand side I'm going to remain with just P. But since I'm seeing 100 on the denominator being multiplied by another 100, I can actually cancel that 100 and also that 100 so that I remain with just 55. Now this P equals to 55 is actually not yet correct. In order for us to show that this 55 is actually the percent, we need to add there the percent symbol. Now that 55 is the number of ladies at work, but this 55% is the representation of the number of ladies in every 100 workers. Also, you're allowed to conclude that 55% of the workers are ladies. If you don't want to calculate your percent like this, you can actually first turn it into a decimal, then you change it back to percentage. Let's see how that's done. So I'm going to go to the next slide. Now this is our formula and this is the same question that we have just seen. So we can also get it using P, which is the percentage. Now even if we are just putting P here, we need to put at the back of our mind that it's P for every 100. So there's that 100 at the denominator. So you need to put that 100 at the back of your mind because we're going to use it later on. So it's going to be equaling to part, which is 55, divided by the total, which is 100. Now from here, I'm going to use my calculator and divide it immediately. And when I do that, I'm going to get P equals to 0.55. Now, the other 100 on the denominator of P that we have put at the back of our minds, we need to multiply it by the decimal number that we have got to change it to percentage. So when you multiply it by 100, you get 55. Again, to show that it's a percent, you need to add the percent symbol. So this is also showing that in every 100 workers, 55 are ladies. Or you can conclude that 55% of the workers are ladies. Now, since the number here is 55 and also the percent is 55, this example may not be a good example for us to understand percentage. So let's see one more example. This is now our second example. The question is saying 70 out of the 250 computers are not working. What is the percentage of those that are not working? Now we are going to use our same formula. Percent is equals to part divided by the total. Now from our question there, 250 computers is the total number of computers. That's going to be our total. Then the other 70 is just the part of the computers that are not working. So our P, or some number in every 100, is equals to part, which is 70, divided by total, which is 250. Again, we are going to do the same thing. We need to get rid of the 100 on the denominator of P, or on the left-hand side of the equal sign, so that we remain with just P on the left-hand side. So I'm going to multiply the left-hand side of the equal sign by 100 and also multiply the right-hand side by 100. And guess what? I'm going to get rid of this 100, cancel it, and cancel that 100. So we shall remain with just P on the left-hand side. This time around, I'm just going to use my calculator and get 70 times 100 divided by 250. So when I do that, I get 28. Now this 28, to show that it's a percent, you need to add there the percent symbol. So this 28 is actually not a number. It's a representation of the computers that are not working. So it means in every 100 computers, 28 computers are not working. Or you can also conclude that 28% of the computers are not working. You can as well first turn that one into the decimal point, then you multiply it by 100 and change it back to percent. So you can do P is equals to part, which is 70, divided by the total, which is 250. And when you immediately divide this, you get 0.28. Now this 0.28, to change it to percent, you need to multiply it by 100. And when you do that, you get 28. Now to show that it's a percent, you need to add there the percent symbol. In every 100 computers, 28 are not working. That's what that 28 means. Or you can say 28% of the computers are not working. Now to better understand exactly what percent means, let's use this real work example. This is actually the same example that we have seen above, and the percentage of computers that are not working is 28. Now let's say we have a green box like this, and this box is containing all our computers, the 250 computers. Then again we bring another smaller blue box like this. Now we decide to pick at random 100 computers from the green box. That will make our green box to remain with 150 computers, and the blue box will have the first 100 set of computers. Now the 28% of computers not working means in the set of 100 computers that we have picked, 28 computers may not work. Now when we bring again another black box like this, a smaller one, then we go to our original box, which is now having 150 computers. Then we pick again at random another set of 100 computers. Our big box now, the green box, will remain with 50 computers. But again in the black box, 28% means 28 computers may not work. So as you're seeing the pattern, in every set of 100 computers, 28 computers may not work. So that's what percent actually means. Now in our box, we are left with 50 computers. Now 50 is exactly half of 100. That means if we want to get the percentage which is corresponding to the 50 computers, we need to divide also our percent into 2. So when we bring another red box like this, then we picked all the 50 computers and put it in that red box. We need to divide our percent into 2 so that we get in every 50 computers, 14 computers may not work. So in every 100 computers, 28 computers may not work. Or you can put it this way, in every 50 computers, 14 computers may not work. So each and every number is always having a representation in that percentage. Now when you see from here, the total number of computers we have picked so far is 100 plus 100 plus 50. That is all our computers. But to get the total number of computers that are not working, it's going to be the first 28 computers that are not working from the first set of 100 computers plus the second 28 computers that are not working from the second set of 100 computers plus the 14 computers that are not working from the set of 50 computers, the last set of 50 computers that we have picked. And when you add this up, you get 70. Now this 70 is the same as the number of computers that are not working in our question. So I hope that one has actually helped you to understand percentage very well. Now, percentage actually helps us to answer questions from all fields of work. Like for example, percentage actually helps those who are in business to answer questions like, what is the percentage of sales this month? So you want to know for every 100 items, how many were sold. Then those one on the health department, they always answer questions like this one. What is the percentage of deaths caused by malaria in our country this year? So you want to know in every 100 deaths, how many were caused by malaria. Then also for engineers, they always answer questions like this. What percentage of boxes of tiles got broken during transportation? So you want to know, in every 100 boxes of tiles transported, how many got broken? Then for us in the data analysis field, we always answer this question. What percentage of data is missing? Now we are very soon going to start seeing how we can handle missing data. And this question is going to be very important. Then apart from answering questions like those one above, percentage helps in comparing two or more results that are coming from different sources or different periods of time. When you convert those results into percentages, it becomes very easy to compare them. And actually a lot more that we cannot talk about it all. Now, for us statistician and data analysts, in most cases we always have the part and the total. So our task is always to calculate the percentage or to get the percentage. But that's actually not the case all the times. There are situations where you are given the percentage and the part, you need to get the total. Or you are given the percentage and the total and you need to get the part. So in all those situations, this formula still applies or this formula still works. Let's see an example of each before we end this video. Let's say we have a question like this. What is 10% of 50? That means we have already been given the percentage. And when you see of 50, it means that 50 is our total. So what we want to get the part that is being represented by that 10%. So use the same formula. We already know that when we see 10%, it means 10 in every 100. So that's like the rational form of 10%. So they are the same. 10 in every 100 and 10% are actually the same. So it's equals to part, that's what we are looking for, and then the total, which is 50. So since we are interested in the part, we need to get rid of the 50, which is on the denominator, on the right-hand side of the equal sign. And to do that, you're going to multiply both sides by that 50. So I'm going to start by multiplying the right-hand side by 50, and also multiply the left-hand side by 50. So I'm going to cancel out the two 50s on the right-hand side. So cancel this 50 and cancel this 50, and we shall remain with just the part. So when I use the calculator and rearrange my equation, my part is now going to be 5. So we can conclude that 10% of 50 is 5. So that's how you do it when you are given the percent and the total. Now let's also see one more example. If you are given a question like 5 is 10% of what? That means you have the percent there and 5 is actually our part, so we want to get the total. You use the same formula again. 10% is the same as 10 in every 100. So it's equals to part, which we have already been given, that is 5, and what we want to get is the total. This time around, since the total is on the denominator, in order for us to get it, we need to first cross multiply it and we bring it on the numerator. So when we cross multiply, our total is going to be this 5 times this 100, then we need to divide it by this 10. So when I do my calculation using the calculator, I'm going to get my total equals to 50. So now we can conclude that 5 is 10% of 50. So that's actually a lot of theory about percentage. Now when you go to the field of work, that's actually not how you get percentage. That one is just to help us understand percentage. You will use a statistical software or any data analysis tool of your choice to get percentage. And for our case here, we always use Excel. That's why in our next video, we're going to start seeing how we can handle percentage in Excel. If you haven't subscribed, please do subscribe. And if you found this video interesting, give it a like and then you share it with your friends. This is a video where we talked about how to get the mod. You can click on it, then you go and watch it. Until next video, WWD 13, then we meet again. Thank you.